At the end of this topic, you will be able to identify an arithmetic progression, compute the general term of an arithmetic progression.
Consider the sequence 4, 6, 8, 12, 20. These numbers denote the number of faces in the Platonic solids. So, they follow a rule but not a mathematical rule. Hence, it is an example of a finite sequence. In the next sequence, 3, 6, 9, 12 and 15, each term can be got from the previous one by adding 3 to it. So it is an example of a finite progression. Sequences following a certain pattern that follows a mathematical rule are called progressions. All progressions are sequences, but it is not necessary that all sequences should be progressions. For example, the sequence of even numbers 2, 4, 6, 8, 10 is a progression as the nth term can be found using the formula 2n, whereas the sequence of prime numbers 2, 3, 5, 7, 11, 13 is not a progression.
If an auditorium has 10 rows and each row has 15 seats, then there are 10 into 15, that is 150 seats. But a typical auditorium is narrower at the front than at the back. In the picture, you can see that each row has 2 seats more than the row in front of it. The front row has 10 seats, the next 12, and next 14 seats, and so on. Now let us see how to find the number of seats in the 10th and 50th rows. In case of 10 rows, we may write the sequence as 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Thus, the number of seats in the 10th row is 28. In case of 50 rows, the above method will involve a lot of work. So let us try to develop a shortcut to find the number of seats in the 50th row.
Consider an auditorium in which the front row has A seats. The next row has D more seats, thus the second row has A plus D seats. The third row has D more seats than the second row, hence the third row has A plus 2D seats. The fourth row has A plus 3D seats, and so on. If there are n rows in the auditorium, the nth row has A plus n minus 1 D seats. Thus, the 50th row will have 10 plus 49 into 2, that is 108 seats.
Arithmetic progression. An arithmetic progression, or AP as it is called, is a sequence in which the difference between any two consecutive terms is a constant. This difference is called the common difference of the arithmetic progression. Therefore, the general form of an arithmetic progression is given as A plus D, A plus 2D, A plus 3D, and so on, where A is the first term and D is the common difference. Let us see some examples for arithmetic progression. As per the first example, considering the first term, A is equal to 2, and the common difference, D, is equal to 3. Now, by substituting the values of A and D in the general form, the arithmetic progression is obtained as follows. 2 plus 3 equals 5, 5 plus 3 equals 8, 8 plus 3 equals 11, 11 plus 3 equals 14, and so on. Therefore, arithmetic progression for this example is 2, 5, 8, 11, 14, and so on. Similarly, let us consider another example where A is equal to 1 and D is equal to 5. Now by substituting the values of A and D in the general form, the arithmetic progression is obtained as follows. 1 plus 5 equals 6. 6 plus 5 equals 11. 11 plus 5 equals 16. 16 plus 5 equals 21, and so on. Therefore, the arithmetic progression for this example is 1, 6, 11, 16, 21, and so on. Also, consider a last example, where A is equal to 9, and D is equal to -2. Now, by substituting these values, the arithmetic progression is obtained as follows. 9 minus 2 equals 7. 7 minus 2 equals 5. 5 minus 2 equals 3. And 3 minus 2 equals 1. And so on. Therefore, the arithmetic progression for this example is 9, 7, 5, 3, 1, and so on.
Let us look at some examples of AP. For the AP 16, 19, 22, 25, the first term A is equal to 16 and the common difference D is equal to 3. For the AP -1, -4, -7, -10, etc., the first term A is equal to -1 and the common difference D is equal to -3. Now for the AP x minus 3b, x plus b, x plus 5b, x plus 9b, etc., the first term A is equal to x minus 3b and the common difference D is equal to 4b. Similarly, for the AP 2a minus b, 4a minus 3b, 6a minus 5b, etc., the first term A is equal to 2a minus b and the common difference D is equal to 2a minus 2b. If the first term of an AP is A and the common difference is D, then terms of the AP can be formed as follows. The first term, T1, is A, which can be written as A plus 1 minus 1 into D. Similarly, the second term, T2, can be written as A plus 2 minus 1 into D. The third term, T3, can be written as A plus 3 minus 1 into D. The fourth term, T4, can be written as A plus 4 minus 1 into D, and so on. Thus, the nth term, Tn, can be written as A plus n minus 1 into D.
In this topic, you have learnt that the general form of an AP is A plus D, A plus 2D, A plus 3D, and so on. The nth term of an AP is Tn is equal to A plus n minus 1 into D for every n belongs to n.